Yeah, it can only do what it's programmed to do.
All right, anyways, try number 2. Absolute value graphs. So if you bought into the transformations that we talked about yesterday, then doing these is actually going to be fairly simple. So, absolute value graphs. So, absolute value graphs. All right, so we're basically going to do transformations. If my thing would work here, that would be wonderful. But our parent function is going to be this, absolute value of x. And to start, and we'll basically do the same thing when we do squares, so it'll be even easier. We do x, y. Remember that y equals absolute value of x. And I'm just going to get a few points here. I'll do like -3, -2, -1, 0, 1, 2, 3, so on and so forth. Okay, so what's the absolute value of -3? And absolute value of -2? And -1? And 0? And 1? So there we go. Pretty easy chart there. And we could go on. The basic thing to keep in mind is absolute graphs yield a V or an upside down V. It's going to be one of those, basically. So if you don't get that on your graph, you know you have made an error. So please don't be stubborn. All right, so let's take a look at what that graph would look like. So here's our 0, 0. And then I got a few extra points here. But that's what the graph looks like. And this is our parent graph. So I'd like you to get your graphing calculators handy. Let's see if I can get this nice and straight.
So how is supposed to be absolute value? I don't see any,
Okay, I'm about to tell you. On your calculator, at least the Casio one, when you're in any mode, it's under options. So you're going to hit your options button. And there's going to be a big list there, and it goes through. You're going to use your function keys to flip through the list, and I think it's under numeric. And under numeric, you're going to find abs.
Hey, so that's where you get abs. You should calculate.
Yes. Okay. Now, depending upon your brand of calculator, it might actually physically put in something like this. And then you move your cursor into this box and you type what you want in there. Or it might type the word abs and then have parentheses, in which case you're going to type in there. Anyways, I just want you to have that handy for now. Please just pay attention. Alright, so let's say that I want to graph this one. Y equals absolute value of x minus 3 plus 2. And I'm going to go ahead and grab that, copy it, and I'm going to go back here. I'm going to paste it now, and I'll hopefully be able to move it up, okay, out of the way. I didn't grab all of it somehow, so here's my absolute value. Now, according from our translations yesterday, I expect to move my graph where? Okay, up to and right 3. So I could take all of these values, right 3 up to, right 3 up to, right 3 up to, and do all of these, right 3 up to, right 3 up to, right 3 up to, and connect all of those. And I see I have moved my graph right 3 up 2. All of those points I have moved right 3 up 2. Now that's not a very convenient way to do it, but that's what's happening. That's the transformation. We're going to try it again, okay? So I'm going to undo all of that, and I'm going to speak what you should be thinking. Okay? So, first of all, this is going to give me where I start. Okay? So instead of starting at 0, 0, so this is the point 0, 0, I'm going to take a look at this, and I'm going to start at 3, 2. So I'm going to start at 3, 2. I plot that point. You with me? Okay, now, I'm going to play pretend. I'm going to pretend that that starting point is the origin. It's not, but I'm going to pretend it is. Now, we just did, take a look at a graph, we did this graph of the parent function based upon the origin. Notice it's in the center. Okay, that's my vertex, my bottom point. That's my point. Okay, so now my vertex is this point, right? You with me? So now, listen, watch. If I go right 1, that's like x equals 1. What's the absolute value of 1? So go up 1. If I go right 2, what's the absolute value of 2? So I go up 2. If I go right 3, that's like x equals 3. What's the absolute value of 3? So I go up 3. Now let's go the other way. If I go left 1, that's like negative 1. So x equals negative 1. What's the absolute value of negative 1?
1.
So go up 1. If I go left 2, that's like negative 2. What's the absolute value of negative 2? So go up 2. If I go left 3, that's like negative 3. What's the absolute value of negative 3? So I go up 3. And I just do it all with respect to that point instead of the origin. Now, I've produced the same graph as I did before. By counting it, I just could do it without having the parent on the graph at all. Now, we're going to want to think that way, especially if I have a stretch factor, which is what we'll do next. I'll let you get that down fairly quickly. All right. Let's take a look at the next one. So I'm going to undo a bunch of things that are on the screen. Actually, I'll just erase the screen. Let's do that. All right, so let's say I want to graph this one. I'm going to have stretch factor this time of a half. Alright, so the first thing I need to do is use my transformations to figure out where I start, where my new vertex is. So, by the transformations, I would have gone left how many? And down how many? So my new vertex is negative 4, 3. See, I changed that value. Oh, it's negative 3. Thank you. Negative 3. So negative 4, negative 3. Notice I changed the value of the x, the thing inside with the x. Any questions where I got that new vertex? So negative 4, negative 3, this is where I start. I am pretending that is my origin. Now notice my stretch factor. With me on my stretch factor? That's going to be important here. Alright, so I'm going to do the same thing as I did before. I go right 1. What's the absolute value of 1? 1, but times my stretch factor of a half is simply a half. So I go up a half from where I was. If I go right 2, what's the absolute value of 2? 2, but times my stretch factor of a half, so I'm going to go up 1. Because half of 2 is 1. Okay, if I go right 3, what's the absolute value of 3? 3, but times a half is 1.5, so I'm going to go up 1.5. I'll do one more. If I go right 4, what's the absolute value of 4? But times my stretch factor of a half, which is 2. So I'll go up from there 2 units. And now I have enough information that I can go ahead and connect those because the pattern's fairly obvious at that point. You see how I'm thinking through that? And I'm going to do the same thing going the other way. I need my negative value. So if I go left -1, what's the absolute value of -1? Times my stretch factor of a half, so I'm going to go up a half. If I go left 2, see what I'm doing is what's the absolute value of -2? Well, it's 2. But I have this stretch factor right here. So I need to multiply it and then by a half, and 2 times a half is 1. So when I go left 2, I'm going to go up only 1. And now I have enough information because of my stretch factor, I could go ahead and connect that. Now I do want arrows at the end of this. Okay? Now you can have fractional stretch factors. We did that in our head because we could do a half in our head fairly easily. But you can have your calculator handy and just type it in and pop it out real quick. You can also use a table of values on your calculator, which if we have time at the end of class, we'll go over how to generate that. Now, our absolute values are going to have some pieces on them that we should be able to identify. So I'll go ahead and go over that. I'll delete these parts right here. And let's just get, like, I don't know, a random absolute value function. Okay, that's good enough. Have my arrows at the end. All right, so down the middle. Down the middle is the axis of symmetry. Other graphs also have axes of symmetry. How do you say that? We have another axis, other functions with an axis of symmetry is going to be down the middle is that concept. And it generally is going to be x equals some number. Now if it's horizontal, it'll be y equals some number, but we are vertical. So in this case, the axis of symmetry is x equals 2 because that's where it goes through the vertex, which brings us to our other thing right here. This point is called the vertex. And in this case, the vertex is 2, -4. Now, if I wanted to, based upon this information, I could go ahead and give my equation. So I know its absolute value because it's a b. So I'd write down, well, y equals absolute value of x. That's my parent. But now, apparently, some transformation has been applied. So normally, I'm right here. My vertex is right here. I see it went down 4. So I have absolute value of x and then a -4. And then I see it went right 2. So what would I put on the inside? +2? -2 is opposite. And there's no stretch factor. So this is the equation of that absolute value. Because we do need to be able to get them off of the graphs as well. I'll do another one. I'll give you a moment.
Can we have one of the questions in homework?
Yep. Okay, let me do one more where we're going to get this off of the graph. Alright, so we'll just get a few pieces. Our axis of symmetry is x equals what?
-4.
-4. What's our vertex?
-4, 2.
-4, 2. So, and now we notice something. Normally, my absolute value goes like up one, right one, but not this one. It's flipped upside down. So this would be y equals absolute value of x. That's our parent. First I'm going to think, well, where did it move? Well, it moved left 4, so that's going to be x plus 4. And it went up 2, so plus 2. But also, there's a stretch, or a compression rather, a horizontal compression of a factor. Well, how much? Well, if I went right 1, what's the normal absolute value of 1? So I expect to go up 1. But what happened? I went down, how much? 2. So I'm thinking there's a compression factor of 2 here. If I go right 2, normal absolute value would be up 2. But look what happened. I went right 2 and down, how much? 4. Is that still twice as much as it should be? You guys sound lost. If I do absolute value of 2, I expect to go up 2. But what happens? I go down 4. So I get down, so there's a negative, twice as much. And that's our equation for that. Maybe we need to practice another one of those. I don't know. There's only, I think, 3 more things we need to talk about. Only 3. Okay. Let's change. Let's do one more graph. I'll do the next thing's pretty simple. What if it's an inequality? If it's an inequality. So what if I had y is less than the absolute value? Let's do 3 times the absolute value of x minus 1. So where's my vertex? What's my x-coordinate? 0. There isn't any transformation there, and -1. So I'm going to start at 0, -1. That's my vertex. So what's my axis of symmetry? X equals 0. So that's this dotted line, that vertical line that's going through there, axis of symmetry. All right, so now I have a stretch factor. What's my stretch? Yeah, so it's times 3. So if I go right 1, see, I'm pretending this is my origin. If I go right 1, what's the absolute value of 1? But times my stretch factor, so I go up 3. And this is reflected, so I'm not going to do the negatives. You just remember that. If I go right 2, what's the absolute value of 2? 2, but times my stretch factor 3, so I go up 6. Alright, so now I need to be careful. If I have a less than or a greater than, my line is dotted because I cannot equal that. So this is going to be a dotted line, so I dot this. And I dot this. And hopefully I actually go through my points. Okay, now I've dotted my line. Now I need to shade. This is less than, which means below my graph. So below my lines. So I neatly shade everything that's below my graph. I am a terrible shader, but you get the idea. And if it was greater than, I'd basically be on the inside here because I'd be above my line. Does that make, excuse me, does that make sense? Huh? Okay, if I have this line right here, and I ask you what's below the line, is the star above or below the line? Huh? It's above. So if I said I want to shade below my line, I wouldn't shade there, I'd shade there. It's below. So this is less than. So I want to shade below my line. So if I take a look at this point, that point should be on my line, it's not. But do you recognize that where I put this star, that that's above the line? And that if I put this star down here, it's below the line? Yeah. So I shade below my line. And if it were greater than, I'd shade above my line, which would basically be the inside. We'll do more with inequalities tomorrow, but I wanted to touch on that today. Let's do another graph. That'll be an inequality with some shading. I'll give you a moment to get that down.
You're basically saying that y is going to be below the line?
Yeah, it's less than, so it's lower. So it's lower than the graph. Okay. Let's say my graph is this. Y is greater than, no. We'll do less than or equal to negative absolute value of x plus 2 plus 1. So what's my vertex? Negative 2, 1. So that's right here. Now, it can be equal to, so I have a solid line. Because it can be equal to. Alright, so from here, I go right 1. What's the absolute value? Oh, what's my stretch factor? So I have a reflection. So instead of going up, I'll go down. So what's the absolute value? 1. 1 times my stretch factor of negative 1, so I go down 1. If I go right 2, what's the absolute value of 2? 2. But I multiply times my stretch factor, so I go down 2. And hopefully that's enough that we see our pattern here. Now, this is a solid line, so I go ahead and connect those. And I should be extending my line off the graph, you know, just so it covers the whole thing. Now I want to shade below, right? You with me? Below?
Yeah.
So where I put this star, is that above or below? And over here? Below. So all of this is below the graph. So that's what I shade. You can also shade above and below lines. Be the same idea. And now we can get to the last thing. And I think we talked about it the other day, so it won't be too bad. Sometimes you're thrown a curveball. Like you're told, graph this. Well now, where's my vertex? I have a thing right here. Now, if this were negative, there's nothing I can do about that. But, if it's positive, I can factor positive numbers out of absolute values. So I factor it out. But I need to include that. So now, what's my vertex? 3, 3. What's my stretch? 4. Now, even if it's nasty, I need to do that. So what if I had like 1/2 x plus 5 minus 1? What do I have to factor out of this? 1/2. So that leaves the x fine. Now I factored out 1/2. That means I'm dividing. So I need to divide that 5 by 1/2. So that's actually going to make it a 10. So now my vertex is -10, -1. With a stretch of 1/2. When you factor out, how did I go from 12 to 3? What did I do? I divided. So what's 5 divided by 1/2? Keep, flip, change. 10. So as weird as it is, 5 divided by 1/2 is 10. Because if I were to multiply that back in, 1/2 times 10 is 5. So sometimes we need to factor those things out.